Imagine a slinky on an escalator. The slinky wants to just slide down, right? That's like entropy, the universe's tendency to get messy and disorganized. Now, picture the escalator moving up, fighting against that slinky slide. That's life. Life is a constant struggle to stay organized, to keep that slinky from reaching the top and going completely flat. Entropy is everywhere. It's why your room gets messy, ice melts into a puddle, and even why stars eventually die. Living things, from tiny bacteria to giant whales, are highly organized. They're like little pockets of order in a universe that's always trying to become messier. Death, then, is like the slinky finally reaching the top of the escalator. It's what happens when life's amazing ability to maintain its order runs out of steam. The slinky goes flat, becoming just another part of the universe's jumbled mess. But don't worry, that's a long way down the escalator ride for most of us. Let's zoom in on life's building block, cells. Think of cells as tiny, bustling factories. They're constantly building, breaking down, and transporting materials to keep themselves running smoothly. And just like any factory, they need a reliable source of energy to power all that activity. Inside each cell, countless processes are happening every second. They build the proteins that make us. They transport nutrients. They fight off invaders. All this work requires a special kind of energy currency that cells can use. Enter ATP. ATP stands for adenosine triphosphate, but you can think of it as the energy currency of life. It's like a tiny rechargeable battery that powers all the work going on inside our cells. When a cell needs energy, it breaks down ATP, releasing a burst of power to fuel its activities. Early life forms figured out how to make ATP using simple chemical reactions. It was like collecting loose change, just enough to get by. But then something amazing happened: photosynthesis. Organisms evolved the ability to capture energy from sunlight and use it to make ATP, like finding a whole stash of gold. This changed everything. Photosynthesis provided a much larger, more reliable energy source, allowing life to become bigger, more complex, and more diverse. It's no coincidence that plants, the masters of photosynthesis, are the foundation of most ecosystems on Earth. But the story doesn't end there. Some life forms took a different route. Instead of making their own energy, they evolved to consume other organisms for their ATP. It was the original power lunch. This led to the rise of predators and prey, shaping the intricate web of life we see today. One of the most important events in this energy saga was the evolution of mitochondria, the powerhouses of our cells. These tiny organelles were once free-living bacteria, but they struck a deal with larger cells, moving in and providing a super efficient way to generate ATP using oxygen. This partnership was a game changer. It provided a huge energy boost, allowing for the evolution of larger, more complex, and more active organisms. Without mitochondria, we wouldn't have the energy to walk, talk, or even think. The human body is a marvel of energy management. We store energy from food as glycogen in our muscles and liver, and as fat for long-term reserves. Every heartbeat, every breath, every thought, it all requires a constant supply of ATP. So the next time you see a plant soaking up the sun, a cheetah chasing its prey, or even just your own hand moving, remember the incredible story of energy and its central role in the grand drama of life. From the simplest bacteria to the most complex animals, we're all connected by this invisible fuel that powers our existence, allowing us to defy entropy and create the beautiful, messy, awe-inspiring spectacle of life on Earth.